You already know that Kreg joinery is one of the easiest, fastest, and strongest joints you can use in virtually any woodworking project. And that means you also know that the strength of the joint comes from the Kreg self-tapping screws. But did you know that Kreg offers an assortment of screws to match a wide variety of materials and projects? You see, there really is no one-size-fits-all screw. And fortunately, selecting the best screw for your project is pretty straightforward once you understand the unique qualities of each screw type and how those qualities impact the success of your project. So we'd like to take a few minutes in this video and tell you about each type of screw. And along the way, I'll share some simple guidelines to help you pick the very best screw for everything you build. The first thing we need to talk about is composition, or what the screw is made of. Kreg self-tapping screws are available in 3 compositions. Choosing the best one for your project is simply a matter of understanding how moisture will affect the screw. For indoor projects where exposure to moisture isn't really a concern, zinc screws are a good choice. These screws are made from case-hardened industrial quality steel and covered in a thin zinc coating. Keep these screws on hand for bookcases, tables, and any other projects that are going to spend their time inside in a dry, controlled environment. Whenever a project might have some exposure to moisture, you'll want to use a blue coat weather-resistant screw. Blue coat screws are also made from hardened steel, but rather than a zinc coating, these screws are coated with 3 layers of anti-corrosion material for a much greater level of protection. These screws are perfect for all kinds of indoor and outdoor projects, like kitchen and bathroom cabinets where dampness can be an issue, as well as benches, planters, and mailboxes that are outdoors and exposed to the elements. Also, with the corrosive chemicals used in modern pressure-treated lumber, blue coat screws will hold up in the long run. Now, for the most extreme outdoor conditions, you'll want to use stainless steel screws. These are actually designed for maritime applications, such as boat building and repair, which means they're perfect for docks and other structures that will be in or near the water, even salt water. These are also a popular choice for pressure-treated projects. If the strength of a Kreg joint is in the screw, then the strength of the screw is in the threads. And Kreg screws come in 3 thread varieties. There's coarse, fine, and combination, or high-low. And matching the right thread type to the material that you're using is key to making good, strong connections. For softwoods like pine, fir, as well as any type of sheet material, whether it's plywood, particle board, or MDF, a coarse thread screw is the best choice. The deeper threads are less likely to cross-thread in the soft material, and they also have more surface area, which means more strength to resist being pulled out of the adjoining workpiece. When working with hardwoods such as oak, cherry, birch, or maple, woods that tend to be more brittle and prone to splitting, you'll want to use a fine thread screw. The smaller threads also mean a smaller overall diameter, so they exert less outward pressure on the wood. That means you're less likely to split a board and ruin a workpiece. One final option is what we call a high-low screw. This screw actually has a combination of fine and coarse threads that provides the best hold in semi-soft woods like poplar while still minimizing the chance of splitting. Next up is head style, and here you've got 2 choices: the Maxi-Lock washer head or the smaller pan head style. In most cases, you'll want to use the Maxi-Lock head to create the strongest possible joint. These screws essentially have a washer built right into the head that provides a large surface area to exert the most pressure over the widest area. Panhead screws are the preferred choice when working with half-inch thick material or when building with extremely hard woods like ironwood, ipe, or mesquite. The smaller head diameter means they fit inside thinner material better and allow the head to sit below the surface of the pocket hole. The reduced shank diameter makes them less likely to split thin or extremely brittle material. Finally, we come to screw length. And I save this for last because it's the most important thing you'll have to consider. Now, in most cases, it's pretty easy to determine the right screw length for your project. Every Kreg jig comes with an owner's manual that has a table to help you identify the proper screw length. That same table is available online at kregtool.com. To match the screw to your project, simply find the thickness of the material you're using, and the best screw length for that material is listed right there. So for example, if you're building a project using 3/4 inch thick material, you'd simply look at the table and see that a 1 1/4 inch screw is recommended. The table includes all common material thicknesses and the full range of screw lengths from the 3/4 inch panhead screw all the way up to the 2.5 inch maxi lock screw and every size in between. Now, where it can get a little tricky, and we get a lot of questions about this, is which screw do you use if you want to join two boards that are different thicknesses. For example, here I've got a 3/4 inch thick board and I want to attach this board that's 1 inch thick. Well, the table doesn't account for that because there are so many possible variations. The best way to figure that out is to just do a little bit of experimentation using some scrap pieces. Whenever possible, it's best to drill the thinner piece. So I'm drilling this piece using the 3/4 inch settings. Then I'll drive the recommended 1.25 inch screw into that pocket hole and I'll use that for comparison. Now, when I set this board up here, we can see a couple of things. First of all, notice that this screw is coming out of the center of this board, which is what we want. And we've got a decent amount of thread in the adjoining piece. But notice how much space there is between the tip of the screw and the edge of the board. That gives us an opportunity to use a longer screw and get a better hold on this thicker, heavier piece. Now take a look at what happens when I step up to a longer screw. This is an 1.5 inch screw. You can see there's still plenty of space between the tip of the screw and the edge of the board. And we've also got a whole lot more thread coming into this piece, so we've got a better hold on this thicker, heavier workpiece. Now this is something obviously that the table isn't going to show you. That's why it's important to do some experimentation to figure out the best screw when you're working with materials that have different thicknesses. Now let's look at this from the other side. For instance, if you have to drill the thicker piece and drive the screw into the thinner piece. It's a little different setup, but you still come up with the answer through experimentation. Okay, so now I want to attach this thicker piece to the bottom of the thinner piece, and I'm going to drill through this face to do it. And I'm going to use exactly the same process. I've gone ahead and made the test piece to show you exactly what's going to happen. So, experimenting to try and find the right screw length here, I started by setting up the jig to drill a 1 inch thick piece of wood, which is what this is. Then I used the screw that's recommended for 1 inch thick material. That's an 1.5 inch screw. And if you take a close look here, you can see that the point of that screw is just going to poke through the face of the plywood, and that's no good. Well, rather than change the setting on the jig, I just backed off the screw length and went to an 1.25 inch screw. Now that's the length of screw that's recommended for 3/4 inch thick material. So the ultimate solution here was to drill this thicker piece using the settings for 1 inch, and then I use the screw that's recommended for this thickness, 3/4 inch. So you might have noticed that there's something of a pattern to this. In the first scenario, when we were drilling the thinner piece and driving the screw into the thicker piece, the proper setting turned out to be setting up the jig for the thin piece and then using the screw that matched the thicker piece. Now when we reversed that, we were drilling through the thicker piece and driving into the thinner piece. Again, those things just switched. We wound up using the jig setting for this thick piece, but we used the proper screw length for the thinner piece. So that's a pretty good rule of thumb, but it's not a hard and fast rule. As these boards get further away from each other in terms of their thickness, say this one gets thicker and this one gets thinner, the experimentation and the trial and error becomes that much more important. So what you need to do is just try these different setups in scrap wood before you start working on your project. That's the best way to find the perfect screw when you're working with boards of different thickness. Thanks for taking the time to watch this video. We hope we've answered all your questions about selecting the best screw for all your Kreg joinery projects. Kreg joinery really is the easiest, fastest, and strongest way to build beautiful projects that will last a lifetime. Be sure to visit KregTool.com for more instructional videos and to learn more about the full line of Kreg jigs and accessories.